guess what's gonna happen on Friday? We're gonna have another quiz. Alright? Okay? So yesterday we did a practice. Right, guys? Remember, yesterday we did a practice? I gave you an old quiz that I gave, and we went through it. Remember that?
Yeah.
So last night, because I don't have anything else to do with my life, I made another little review sheet. So we're gonna nail this. Here we go. Even, odd, or neither. So let's refresh our memories. I have to check two symmetries. If I am even, I have symmetry about what? Y-axis. So I'm going to do my y-axis symmetry. If I'm odd, origin. So I have to do these two symmetries. So what is the test for the y-axis? Change the sign on x. So this is y here. So y equals 3 negative x squared minus 11. So I take out the x and put in negative x. Now what happens here? What does that do? Isn't that just 3x squared minus 11?
Yeah. Even.
And it matches the original, right? So therefore the function is even. Okay? How about the next one? Y equals 5x cubed plus 2x minus 8. You want to do odd first for this one? We're testing for oddness. We have to do our origin test. And what's our origin test? Y and x, both negative. Both negative. Going from here to here. Quadrant 1 to quadrant 3. Both negative. So, here's my problem. So negative y equals 5 negative x cubed plus 2 negative x minus 8. All right, let's clean it up. What happens here? 5 times negative x cubed, is that going to be a positive or a negative term? Negative 5x cubed. Negative 2x minus 8. And then I gotta get y, so I'm gonna divide by a negative. So that'll be 5x cubed plus 2x plus 8. Look at it carefully. Does it match the original?
It's minus 8.
It would if it weren't for that, right? So therefore this is not odd. So let's check even. Even is just change the sign on x.
Can we just go to where we had it done after we did x's?
What?
Like before we subtracted, or before.
Oh, okay. So Michael says I'm going to cheat a little bit, or not cheat necessarily, but skip some steps. He said, I know I'm going to change the sign on x, so won't it look just like this, except that'll be a positive y? So yeah, you can do that. That's all right. So that'll be, what is that? Negative, oh, that's not going to work, is it?
No.
No. So this one would be a neither. So that one was even, this one will be a neither. All right, how about negative 3x? Let's try odd. So negative y equals negative 3 times negative x. Right? So negative y equals 3x. And y equals negative 3x. So that one is odd. Okay. Now on your quiz, there's only going to be one equation. We just practiced 3 times. We have an even, an odd, and neither example up here. Okay? Yep.
So for the y, finding the y-axis, which is even, you change just the x's.
Yep.
And then for the origin, you change all of them.
Yep.
Okay.
For the x-axis, you change y, and for the identity, you switch y and x. So by test day, you need to know all your tests of symmetry. All right, but here, this question's just even more.
So still test next week after the post office.
Test next week, yep. We have to finish one before. All right, name a BFF that is decreasing from negative infinity to 0. So think about graphing. We're talking about over here, negative infinity to 0. Name a BFF that is decreasing, going down over there.
Cubing function. Absolute value.
Cubing function actually is increasing over here, isn't it? What did you say, Jimmy?
Absolute value.
Absolute value's coming down. That would be an example of one. Can you think of another one? How about the quadratic, the squaring? Isn't that coming down
Oh,
over
yeah.
here? The V and the U have the same characteristics. Just one is rounded and one is pointy, right? Okay. The limit as x approaches infinity, this is your end behavior. So as we go this way, we're going up. And as we go this way, we're going up. Quadratic, absolute value. That might be it. Increasing on the entire domain. So left to right, your pencil is going up.
Linear.
Linear, cubing,
Exponential. Or no.
yeah, exponential is going up.
Square root.
Natural log.
Natural logarithm. Now be careful, we gotta be careful on that one, because the natural log doesn't even exist over here. Remember, the natural log starts at 0. Well, yeah, okay? So probably take that one off the list, because the whole negative infinity to infinity thing.
So what about square root?
No, same thing with the square root. It's increasing on its whole domain, but its domain is not negative infinity to infinity. All right, speaking of domain, find the domain. What's the domain of A? Oh my gosh, what's the domain of A? X cannot be
One. Or no.
negative 3. Why can X not be negative
Because
3?
then it would be
Can't have a 0. You can't have a 0 on the bottom. So your domain is negative infinity to negative 3 and negative 3 to positive infinity. Think about what that looks like on the number line. It's the whole number line except for negative 3, right? So that's why it looks like that. That's your domain. How about x cubed
All
plus
reals.
4x? All reals. Why is that all
Because there's no
reals?
denominator and no radical.
No denominator, no radical. Michael's been paying attention. Good job. Now what about C? So we had all kinds of problems.
2,
X cannot be 2,
And
and X has to be bigger
Positive.
than or equal to
0.
negative 5.
Or negative.
Whatever is under the radical has to be positive. That means X has to be bigger than negative 5. So if I look at it on the number line, here's negative 5, and I'm going this way, but I have to skip over 2. So negative 5 to 2, and 2 to infinity.
When you do brackets, when the negatives.
You do brackets when it's included, greater than or equal to. All right. Number 4, find all of the asymptotes, holes, and intersects. So what are we gonna do first with problem number 4? Factor it. So, let's see, 2x squared plus x minus 6. So 2 plus 3 minus 2. Right?
Cancel.
Yep. we can cancel.
It's a
So
whole as
that
well.
means we're going to have a hole.
That's so good.
So
Could
your
be.
job is to find all those things. You're definitely gonna have a hole, which is a point, and the x of the point will be -3. And how will I find the y of the point? Plug in -3 right here. Don't go back and do it the original, you're gonna have problems, so do it right here. So 2 times -3 minus 2, -3 plus 1. Alright, so -3 minus 2 is -5 times 2, so that's -10 on top, -2 on the bottom, so that gives me a 5. Now, what about a vertical asymptote? Okay, this is your problem now, look at this right here, that's your problem.
-1.
Your vertical asymptote is x equals -1, because x can't be -1, right?
Yep.
What about your horizontal?
2.
Y equals 2. Don't we have 2x over 1x? Right? And then your intercepts. So I don't know where, but somewhere this thing crosses the y-axis. If it crosses the y-axis, it's 0 comma something.
Yep.
So I'm gonna put 0 in here, and my picture is totally wrong. I'm gonna put 0 in here, and what do I get?
4 over
-4. So my y-intercept is 0, -4. Now, somewhere I cross the x-axis, and that means it's something, comma 0. So I'll let y, this is y equals, I'll let y be 0. So I have 0 equals 2x minus 2 over x plus 1. So I'm gonna multiply both sides by x plus 1. So 0 equals 2x minus 4. Add 4, divide by 2, it looks like my x-intercept is at 2, comma 0. Your x-intercept is always gonna come from right here, right from the numerator. Right from the numerator. Okay. Number 5, sketch. All right, this is a lot going on here. What general shape is this gonna be?
Absolutely, I
A V. However, there's a negative out in front of it.
means it goes upside down.
That means it's gonna be turned
Upside down.
upside down. And it's gonna be moved
Left 1.
left 1 and up 2. So -1, 2, upside down V. Is that okay? All right, consider this picture. What is the domain?
All of this.
Everything. Left and right, forever and ever and ever. How about the range?
-2.
-2 to infinity? The lowest point's -2? and it goes all the way up forever. Zeros, what do we mean by zeros? X-intercepts, x-intercepts. So your zeros are -3, 0, that's one of them. 1, 0 is another one, and 3, 0. Everybody okay with that? It's where we cross the x-axis. By the way, on your quiz, how many zeros did your equation have?
One.
Just one, it only crossed one time, right? And that's fine. It's fine. All right, how about increasing? Where is this thing increasing?
From
From -1 to 0, no, from
From
-1 to 1. We're looking at x values. We're looking at x values.
And then 2 infinity.
And then again from 2 to infinity. Look at the picture.
No, it doesn't say it is, yeah. Two to.
Oh, actually, I gotta be careful.
Yeah, because it goes flat.
So 2 to 4, and then
And then from
5 to infinity.
Is it?
Oh.
Thank you.
Five, yeah.
Oh,
It's got a flat line in there. So it's only increasing from 2 to 4, the beginning of the flat line, and then the end of the flat line. Thank you, you're right.
Do we have to do all of them?
Yeah.
So what about like from -3? Is that because it's going that way?
Remember, when you talk about increasing, it's left to right.
Oh, it's left side.
Always left to right. All right, now where is it decreasing?
-1 to -3.
From
-5 to -3.
negative infinity all the way to -2. Remember, we're looking at x values. Negative infinity to -2, it's coming down that whole time. And then when does it come down again? 1 to 2. And is that it?
Yeah.
That's it for coming down. Okay?
So this one's our first.
Yep. Not that many problems, right? Something like that. All right. Let's get our notes out. Let's wrap up 1.4 if we can.
I did this one.
Okay, everybody. All right. H of f of 2. This means the same thing as this. We can either write our compositions with the open circle or just with parentheses and brackets. These two things mean exactly the same thing. We started talking about this yesterday, the two-step problem. What's the first step? Put 2 into F. Yep. Put 2 into F. And what do we get when we put 2 into F? 8. Everybody good so far? And then, second step, take that 8 and put it into 8. And we get 16, and that's the final answer. Okay, so what does this mean again? Put 2 into F, get an answer, and then put that answer into H. Now when I'm talking about putting it in, I mean take out the X and plug in the number you want in place of the X. All right. What's a little bit different about C?
We put the H function into the X.
There's no number, right? So this says, take the f function, which is 3x plus 2, and take the whole darn function and plug it into h. So we'll have h of the whole function is going to equal 2 times the whole function, which would be 6x plus 4. So when there's no number, you're taking the whole darn function and plugging it in for x in the other function. Now, this, you have to be careful. This is tricky notation. I know it's mine, and no one ever does this except my siblings. How do I know how to do this.
Just do this.
I'm not really good at my phone, but there we go. I turned it on.
Written notes, so.
All right, so f of g, this means f of g of x, okay? Now, sometimes we get confused with multiplication when functions are involved. If it's a multiplication problem, you will literally see a multiplication. Okay, so when f, g are written right next to each other and they're functions, it's a composition. So this means this. All right, so what does this mean? Well, take g of x, the whole function, x squared minus 1. That's g of x right here. Here's another way of writing it, if that makes more sense to you. All these mean the same thing. All of these are ways of writing the same problem. So take your whole g function and put it in right here. So f of x squared minus 1 is 3 x squared minus 1 plus 2. So 3x squared minus 1 when I distribute and collect like terms. If we have time at the end of the period, we'll practice a couple more of those. Those are a little tricky sometimes, but that's the idea. All right, now we're shifting gears, talking about an important calculus topic, the idea of implicit functions. Does anybody know what this looks like? What that is? You should know.
Circle.
It's a circle. Centered where? Where's the center?
25?
No.
I don't know.
The origin.
Um,
And the radius is 5. So if you graph this, this is what it would look like. Okay? Now, why are we talking about this? Well, first of all, is that a function? No, that is not a function. And so if I told you to graph it on your calculator would say, I can't, because I'm a function machine. And that's not a function. Think about it. When you go to put something in your calculator, don't you have to put it in as y equals?
Yeah.
You can't put it in as y squared. You have to put it in as y equals. So in order to make our calculator graph this, you're going to find the implied functions, what are called the implicit functions. So I want you to go ahead and move that x squared over. And then I'm going to have you square root, because if I do that, now I will have y equals, but be careful, y equals what? Plus or minus the square root. So you're actually going to get two equations. you're gonna get y equals the positive square root and y equals the negative square root. These are called the implicit functions. Here's what I want you to do. I only want you to graph one at a time, all right? So I want you to graph just that top one. So let's set our window at Zoom 6, standard window, and let's type in the square root of 25 minus x squared. And hit graph. Now, what did you get? You did not get this. You got only the top half of it
Yeah, but it's.
because you graphed the, we'll talk about that in a minute, Michael, just hang with me. We graphed the positive root. Guess what's gonna happen when you graph the negative one?
It's not over. Or the bottom.
You're gonna get the bottom one. So go ahead and add that one in. So leave them both on there. So for y2, do negative the square root.
Whoa.
And you get the bottom half of the circle. Now, Michael is up here, like, nervous because mine doesn't work in a circle.
I got it.
Mine looks like an ellipse. And he's right. I want you to go to Zoom. And number 5 is Zoom Square. Hit Zoom Square. And guess what that's gonna do now? That squares up your screen. So your picture is now perfect and not warped. You need to zoom square, hit zoom, option 5, and then you get a circle. So let's talk about that for just a quick minute. What shape is my calculator screen? My calculator screen is not square. My screen is rectangular. So everything you graph is going to be stretched this way because that's where the screen is set up. So if you want an accurate picture, if you hit zoom square, it will square the screen. It will give it the dimensions it needs to pretend that it's a square. So then you get your circle, right? Lesson here is, when you want to graph something that's not a function, solve for y. Solve for y. And then you'll have your implicit functions. All right, let's try the next one. This is not a function. You cannot put it into your calculator. So, what are we gonna do? It's not a circle.
Take y.
I'm gonna take, actually, I'm gonna leave y, take x over, and then square root. But what do I have to remember? Plus or minus. So your implicit functions, guys, make sure you can write these down because that'll be a test question. What are the implicit functions? And in this case, they will be square root of 25 minus x and negative square root of 25 minus x. So let's see what those look like.
What the heck?
Yes, it's because it's the window.
Wait, what did
We need to zoom out.
I got this.
Window.
It's not right.
That's not right.
You can't see the whole thing,
Yeah, it's like.
so I have to make an adjustment. Quincy?
Mine don't graph.
Okay, well, I don't.
Okay.
Ooh, I did 50 or like.
If I change my window
I did 50.
and maybe, yeah, let's try negative 50 to 50. Yeah, that works.
For that,
So
are you changing the X ones or
I changed my x's to negative 50 to 50, and I left my y's, and I got my picture. What is that? Did you get a parabola?
Wait, why is mine?
Well, you made your Y style.
I got a sideways version. What is my?
Computer dog. So, my x's are negative 50 to 50, and my y's are negative 10 to 10.
Oh.
So that's my window. These are my equations. If you do it right, you're going to see this picture, which is not a function, but are each of the pieces functions. Is the top half a function?
Yeah.
Yep. The bottom half is a function. So that's why these are called implicit functions. They are functions. But when you put them together, you get something that's not a function.
So the answer is just the like plus one and the negative
These
one.
are the answers. Those are the implicit functions. All right, next one. All right, so the first thing I'm gonna do is move that X. Now, obviously, I'm not square rooting this one, it's not a square. So I want you to think back. If you took the absolute value of something and you knew it was 3, for example, you knew it was 3, then what could be the something in there? Could be 3. In other words, y could be 1 minus x, it could be that number. But what else could it be besides 3? Negative 3. So y could be negative 1 plus x. So if you are inside the absolute
The
value,
implicit functions are those, right?
so these are your implicit functions. Yep, these are your implicit functions.
Should we get?
So let's see what we get when we do that.
Is it like a type?
Let's see, where are you? 1 minus x and negative 1 minus x.
I got an X. Yeah.
Now, we need to talk about that because that actually is not, that whole thing is not the answer. When you got those are your implicit functions, okay? Those are your implicit functions. But when you graph them, you should have gotten something that looked like this. Okay, now I want you to go back to this equation right here. When you take the absolute value of something, it has to be positive, right? Has to be positive. So we can't look at this whole thing. We can only look at where the x part, where this part right here is going to be positive, and that's out here. Is that where x is positive? No, I want the other half, I'm sorry, I want this half. That's where it will be positive. That's a little tricky, but think about this for a second. If I put in a negative x value, will this be positive? Put in a negative x value, like negative 5. Will this end up positive? Yes, that's okay. I need this to be positive because absolute value equals this. So I need this to be positive. And this is only positive when x is negative, basically. So this is your answer. Now, that should make sense to you. Because what is an absolute value shape? A V. But when it's the absolute value of x, it's a V up or down. When it's an absolute value of y, it's a V left or right. right? Now, how would you know when this was going down? There'll be a negative effect, right? So this one went left because there's a negative in front of that X that changes its sign and makes it go left instead of right.
So if it was plus, it would go
You
right.
do that. If that had been, well, the equation could be different, but if that had been plus, yes, we would be looking at that. All right, couple more. Stay with me.
Negative X and positive X.
You just so done with this one.
All right, what do you think about this one?
Square both sides. Y equals negative X, Y equals positive.
So y equals x or y equals negative x?
Yes.
Probably without graphing that on your calculator, you know what that looks like.
Yeah.
Now, are all those okay? Yeah, they're all okay. That's fine. There's no absolute value here to make things have to be positive. It's fine. That's fine. And I don't know if you're paying attention. The big idea here is that we want to be able to find the implicit functions. Sketching them is kind of secondary. Let's make sure we can find them. So last one. Does that look okay so far? So what are my implicit functions? Y equals x minus 1,
Same thing.
or y equals
Oh wait.
negative x plus 1?
Just gotta go up. Yeah.
So it's gonna be exactly the same picture that we just did, except instead of taking the left half of it, we're gonna take the right half, because that's a positive x, so we're gonna take the right half. So it'll be a V this way.
We have to draw that. Can you like draw that?
You won't have to draw freehand, you might have to put in your calculator. All right, if we get through these next three, I'll shut up, okay? How about that? That's the deal. Here we go. Number 4. Somebody has made, not these functions anymore. Somebody has an F function and a G function, and they have put them together and ended up with an answer of 2x minus 1. So in other words, they put G into F and got that. This is really easy. What are the two things that this function is accomplishing? It's multiplying by 2 and it's subtracting 1, right? Which order is it doing that? What comes first? Multiplying by 2. So when I build my composition, the first function, that's the first one, has to multiply by 2. So G is going to be 2x. And then the second thing that has to happen is subtract 1. So F is the function that subtracts 1. Now that's not 2x minus 1, that's x minus 1. Because remember what you're going to do is, you're going to take this 2x and plug it in there. So you need two functions. You need one that multiplies by 2 and one that subtracts 1. And you need them in that order. So the first one times this by 2, the second one subtracts 1. Harper's holding her head like, oh my gosh. All right, let's look at the next one. Same idea. what are the two things that are happening in this function right here? What are the two things? We have to add one, or add two, add two, and square. In which order? What has to happen first?
Swearing.
Wait, time out.
No, add
Time out.
two.
If I said plug 3 in here,
Oh.
wouldn't we add 2
Yeah.
and then square? So G has to be the function that adds 2. And then F has to be the function that squares.
Because you're a for X.
And then the last one, I forgot to put a problem on, so I'll just make one up. Make this one a 3-parter. How about 2x plus 5 over 7? Now, in this problem, there are 3 things happening. What are the 3 things that happen? When you pick a number and plug it in, what happens? You have to multiply by 2, you have to add 5, and you divide by 7. And don't you do it in that order? That order?
Yeah.
If I said plug in 6, wouldn't you do 2 times 6? Add 5, divide by 6. So that's the order that it's happening. You only have 2 functions, F and G, that have to accomplish 3 things. So we'll put 2 in one function. So, alright, what will G do? G is my first function, and it has to multiply by 2 and add 5?
Yeah.
And then what does F have to do? Divide by 7. Remember, when you're building your functions, you're using X, just X. What if we did, the first function was only 2x? Then what would the second one have to do? If the first one only did this, then what would the second one have to do? Add 5 and divide by 7. So x plus 5 over 7. Right? This is called decomposition. Because instead of putting them together, you're taking a big function and taking it apart.
Just put 2x into X.
Yep. Yep.
With the other one, you just put X into X, I guess. Or what would you do? That one, yeah.
It's like
Into the X, okay.
Imagine if you 10 reps of 10 reps of
The quiz is over.